Hello and welcome back to NeetCode Easy. I'm Neha and today we have problem 11, 2-sum part 2. In this problem, our array is sorted and we will have to return the indices of two numbers such that they add up to a given target number. One more thing is the index count starts with number 1 instead of 0. Let's see the example 1. It has an array as input and target number 3, and the output is 1, 2, as the sum of 1 and 2 equals target 3. Therefore, we return the index value 1 and 2, as our index starts from 1 instead of 0. If we look at the constraints here, we have three informations. The array will always have at least 2 numbers and at most 1000 numbers. The array contains both negative and positive numbers ranging from -1000 to +1000, and the target also falls within this range. Now, if we think of the simplest way to solve this problem is, we could take each element and try pairing it with all the others to check if the sum equals the target. Let's take the example 1 input numbers on the target. So at I equals 0, here we will check 1 with all the other elements by adding it and then matching it with the target. Like for example, we will sum up 1 with 2, we will add it with 2 and check what we get. So in this case, we are already getting it in our first step, but in the actual process, what we'll do here is we take the first number and check with all the other elements. If we find the sum, we return the indices value of the two numbers. And this is a brute force approach. But in this approach, we are just scanning through the array with two loops. One loop goes for each element and other loop checks each element with the other element and then compare the sum with the target. And this takes big O of n squared time. And in our problem, it's not recommended here. So we have to come up with a solution with big O of n time. So the better approach here is two-pointer technique. We start with 2 pointers, one at the beginning and one at the end of the array. So here, first pointer starts here to the left and second pointer starts at the right, at the end of the array. So left pointer has 1, right pointer has 4. We combine them and then check if it matches with the target. But here we have 5, which is greater than 3. So we move our pointer one step forward. So now it points to 3. Now if we add it with 1, we get 4, which is again greater than 3. So we move our pointer one step forward. So now left has 1, it doesn't change. Right has 2 now. So we add them and then we get 3, which is exactly what we need here. Once we get it, we return the index value of 1 and 2. The index value of left pointer and index value of right pointer, which is 1, 2. since our array index starts from 1 instead of 0. So now we understand the algorithm. Let's start writing our code. I'll comment this line out to make some space here. And as always, we will use Python here. First, we need 2 pointers. Let's start with the first pointer, left, and it will start at index 0. Then we start the other pointer, right, and this will start from the end of the array. And how do we get there? We simply subtract 1 from the size of the array. So len of numbers minus 1. Then we start a loop, a while loop, which checks while left is less than right. So while left is less than right, while this statement is true, we calculate the sum of the numbers of our 2 pointers. So result equals numbers left plus right. And then we compare the sum with the target. If they are equal, we return left and right, but with adding 1 as the index starts from 1 instead of 0. So if result equals target, we return left plus 1, right plus 1. Another condition will be if the sum is less than the target, it means we need a bigger number, so we move the left pointer forward as our array is sorted. If result is less than target, so in this case we move left pointer forward, left plus equals 1. Otherwise, the sum is greater than target. That means we need a smaller number. So we move the right pointer backward. Right minus equals 1. And that's it. Let's run the test cases. Okay, I'm missing a letter here, numbers. Yeah, as you can see, it's working well. So if we see our solution here, we are not using any extra space. So the space here is big O of 1. And our while loop runs through the entire array once. So the time complexity also becomes big O of n. And that's how we solve this problem using 2-pointer technique. Our next problem is 3 sum, problem 12, and I'll see you in the next one. Bye bye.